Okay, hi. Today I'm going to go over a rather difficult concept to understand in physics. I'm going to talk about impulse, and I'm going to do so in a simplified way that's easier to understand. So we're going to go over the definition, what it is, and what it means. So we're going to start by noting that force equals ma. That's Newton's second law. But then we also know that A is equal to delta V over delta T. So what I'm going to do is I'm going to substitute this in for A, wherever we have it. So we get F equals M delta V over delta T. So far so good. Now I'm going to replace the deltas. Remember, delta stands for change in. I'm going to replace the deltas with D's. This is where it gets a little tricky with mathematics. A D is the same thing as a delta. It just means delta at an infinitely small level. So when we shrink delta to get infinitely small, it turns into a D. Now I'm going to do some rearranging here. I want to get dt to the other side. I want to get rid of this fraction, so I'm going to multiply both sides by dt. Some simple algebra here to cancel it out. So now we get f times dt is equal to m dv. Gonna do a little bit of math here, a little bit of calculus. Whatever we do to the left side, we want to do to the right side. And don't worry about what this means. This just means integrate. And what the squiggle integration means, this cancels out the d. So this and the d cancel each other out on both sides. So we're left with f times t is equal to m times v. This is the definition of impulse. And if we think, mass doesn't usually change. And if we assume the velocity is a constant number, we get force times t is equal to a constant value. Which means that since we want the product of force times t to be constant, if force increases, t has to decrease. If this goes up, this has to go down so that the number can stay constant. On the other hand, if this goes down, this has to go up so that the number can stay constant. So as force increases, time decreases. And that makes sense because if the time is small, you're applying the force all at once. If the time is large, you're spreading the force over a greater amount of time. Now, how does this all tie together to forces and momentum? Well, what happens is this value, m times v, we don't really call it constant in physics. There's a special name we use instead of constant. We call it momentum. So that's the relation between impulse, force, and momentum and velocity.